Okay. Once again, page 281, Gorman. And we're going to create it much the same way we did the last one. I'm going to do a start node. And I'll talk about what exactly we're doing here in a second. But I just kind of want to get this data in. Well, before I dig into it any further, what we have is a solution where the Gorman's office is number 1 in that graph, and he's got to get to number 6, and he wants to find the most efficient way to drive there. So this is like the different ways you could drive from here to San Francisco. There's probably 30 different ways. Yes?
What page are you
281. Okay, that little graph in the upper right corner there. And so these are all the different ways. So each node is, picture each node is like a different city, and each number is a distance between those places, and this is a way you could figure out the most efficient way to get from point A to point B, point A being 1 and point B being 6. This is an important kind of problem. This is a very common problem done every day in business. What's the most efficient route? To get someplace, you typically say, oh, I could just do the math and calculate each possible route, but say I put 25 nodes on here. Well, that kind of changes, doesn't it? And you could see in a city, going from point A to point B, and you have, say you're a truck driver and you're doing local deliveries and you've got 25 stops and you need the most efficient way through everything. Well, getting and doing all 25 possible stops, and and there's hundreds and even thousands of possible routes to calculate. This is easier. Of course, this problem is on a smaller scale than that would be. So that's the value of this. There will be a problem just like this on the second midterm and on the final. So my advice, take it or don't take it. Once you learn how to do this problem, do the sample problem, do the homework problem, do the first midterm problem, and do the second, and do the final exam problem. And you'll be done with a quarter of the final exam. You know how to do it. There's no reason to wait. You don't have to relearn it later. You can have all of that hammered out this afternoon if you want it. These problems are about 15 minutes, 20 minutes. So if you want to get ahead, I highly recommend doing that. It's just a smart way to go. If you want to wait and enjoy the pressure of the final exam later off and relearning stuff, hey, more power to you. That's cool. But if you if you don't have time today, tomorrow, while it's still in your mind, might as well get head start on that.
The first midterm problem and the first final.
I don't know which, but it'll say chapter 6.
Oh.
Yeah.
But this will be on YouTube, right? So we can
Yes.
look it up.
You can look it up later if you want. Yeah. And on the final exam, like I said, I recommended to some of you, do final exam 1 that's my recommendation. It's easier. And if you open up the Word document that says there's 2 final exams, you get to choose which one you want to do. If you open up the first document, this will be, I think, the first problem in there. All right, so let's go ahead and tackle this. The start node, so for each node, we're going to have the different options. So start node, we have 1 through 5. Okay, where we can start at any node. We're not going to start at node 6 because that's where we want to end up. So we're going to have start nodes 1 through 5. End nodes, we're going to go 2 through 6. Those will be our end nodes because we're not going to end at number 1. Now, we could enter in every possible combination. You could go start node 1, end node 2, start node 1, end node 3. Then you go to 2. You can go 2 to 3, 2 to 4, 2 to 6. You could also go 2 back to 1. If you enter in one that goes backwards or is not needed, it doesn't matter. Solver will zero it out. So you can never enter in too many of these. So don't be worried about, like, well, it looks like it goes backwards to me, so I'm not going to enter it in. That's your risk. You can do that if you want. But remember, too, that if you do that, sometimes these aren't to scale, and it looks like it's going backwards, but it really isn't. And then you go to number 4, from 4 you can go to 4 to 5, 4 to 6, or 4 to 2. So we're just going to enter all that in. There's no real rhyme or reason to how I do it. You can do it however you want. I'm going to go start node 1, end node 2, and this will be distance. And the distance from 1 to 2 is 25. You can see these are not to scale, so don't let the drawing fool you. You can see 1 to 2 is 25 and 2 to 3 is 3, and it's like the same distance. Not to scale. Once again, don't try and do it in your head. It'll mess with you. Okay, and then I'm going to go to start node 1, end node 3. and that distance is 20. And then we're going to go start node 2, end node 3, and that distance is 3. And then I'm going to go start node 2, end node 3, not end node 3, end node 4, distance is 5. Start node 2, end node 6, distance is 14. Okay, I think those are all. I'm not going to go back to 1. I'm going to risk that one, but that's not the most efficient way to go. So those are all of them for 2. Now I'm going to go to 3, start node 3, end node 2. I wouldn't skip that one. I don't know if that's, that to me that looks risky to skip that one. So I'm going to enter it in just in case. That's a distance 3. Start node 3, end node 5. And that's a distance of 6. Oops. You guys are with me on what I'm doing here?
Can you not do start node 3 and node 1?
You could do it if you wanted. I'm going to risk it, but you could. I'll just put it in. Why not? We'll
So
have,
even if you do it and you don't do it, you probably get the same answer.
right. Yeah. If it's one you don't need, solver will eliminate it for you, so you don't need to worry about it. So start node 3 and node 1 will put 20. It won't matter whether you have that or not, because that one is obviously backwards. But just in case, if it makes you feel better or you don't want to risk it, cool, doesn't matter. Okay, start node 4 and node 2. I'm going to go ahead and go back on that one because it's a small number. So start node 4 and node 2, we end with 5. Start node 4 and node 5 is going to be 4. Oops. Come on. Start node 4 and node 6 is going to be 4. If I enter the wrong info, somebody yell at me, because that's when I'm talking and doing this, I mess it up sometimes. Okay, we've got start node 5 and node 4 is going to be 4. Start node 5 and node 6 is going to be 7. And just to be safe, let's do start node 5 and node 3. We know it's not going to go backwards like that. So I'm going to leave that one out. Okay. Next, we have decision variable. This is all done for solver. So the decision variable is going to be your yellow cells.
So we don't have to do the 6 at once.
I'm not doing it.
Is it built backwards?
Yeah, you can do it if you want. Let's see if we get a different answer. But I don't think it'll matter. Because, to me that looks like it's pretty obviously backwards and won't be the most efficient way. All right, the decision variable is going to be a 1 or a 0 for this. Solver is going to put a 1 or a 0. 1 meaning, yes, that's an efficient route, and 0 meaning, no, it's not. And solver will tell us to do this. We'll have solver do that for us. So we're just going to keep right on moving. And I'm going to go ahead over here and put node under G6. So, and we're going to do something very similar to what we did before. We're going to have node 1, 2, 3, 4, 5, and 6, because those are our 6 nodes. If you had 9 nodes, you're going to put 9 of these. And we're going to have node out, and we're going to have node in. Okay, so wherever we have node 1 on the far left, meaning we're leaving node 1, that's what the far left is under column A, we're going to add all those together. We're going to add the column D, corresponding column D. You'll see what I mean. So for this one, I'm just going to do a sum, and I'm going to go these two right here, because they both say 1 on the far left. Okay, and then for everything that says 2, which is these 3 right there, I'm going to highlight those. And for everything that says 3, everything that says 4, everything that says 5. Okay, and for 6, we put 0. Because nothing's starting at 6, so we put the number 0. Okay, of course, they all look like 0 right now, but there's just a number 0 in that one. Okay, for n, what's going into number 1? Nothing. So are you guys with me?
Yes.
Okay, just making sure I'm not going too fast. For n, there's...
We put
No, there is one in there.
Yeah.
3 to 1.
3 to 1, 20 distance.
Okay, say again. Oh, this is a mistake?
Yeah, there's one.
That's
in
going
there.
into 1.
We went backwards, 3 to 1. B12.
B12, 3 to 1 is 20.
It's going into.
Right.
It's going into
Shouldn't
1.
that be counted?
Oh, I see what you're saying. Since 1 is your starting point, for the sake of solver, no, you wouldn't count it. It'll mess up solver. To be honest, it'll mess up solver if you do that, because you would never in real. We put that in. I probably shouldn't have put that one in, but it will. You're never going to go back to your starting point. That could never be the most efficient route. To get from San Francisco would be the most efficient route. Would never be to go from here to Bakersfield, then back to here. That wouldn't make
So
sense.
never go back to 1.
Never go back to 1. I shouldn't have put that one in.
Right.
No, I see what you guys are saying. So this one is going to be 0.
Can we just delete that that row?
That could cause more problem. I mean, you could, because then you're going to mess up your references to all the stuff in here. So I just leave it. Hopefully it won't matter. I forgot about that. I apologize that you can't go back to 1. If it doesn't work, we'll link an adjustment. Okay, and then so for n, we pick everything that goes into number 2. So wherever number 2 is the target, so we're going to sum. So wherever there's a number 2, we're going to use that cell. So that's going to be, for me, it's going to be D5, D10, D13. Those are all the 2s I see there. Okay, and then so for 3, so I look for all the 3s, that's going to be D6, D7, and that's it. You guys see what I'm doing here? All right. For everything that ends in a 4 in column B, we're going to go D8, D16. I don't think I'm missing any. And everything that ends in a 5, we're going to go D11, D14. And then for everything that ends in a 6, we're going to go D9, D15, and D17. Okay.
What was the first one?
The first one is you sum the 2 that are end in 1. Where 1 is, I'm sorry, the first one is a 0. You just enter 0 in. I was doing the second one. Okay, next we're going to go, I'm going to title it net shipments, but you don't even need to title it if you don't want to. Doesn't matter. We're going to actually do the opposite of what we did for the previous kind of problem, so you can get tripped up on this. Oops, why am I way up there? We're going to go equals H7 minus I7. So that's the opposite of what you did for the other problem. So H minus I. Okay, then we're going to drag that down.
Why is it the opposite?
We're kind of having to manipulate solver to do our bidding here. And we're going to use binary. Well, it's really hard to explain without making it more confusing first. But we need to know the net number of shipments. So we need a number that's going to... let me finish and then I'll come back. Because I'm going to have to explain what I'm going to do next in order to answer your question. So I'll finish and come back to your question.
Where did that F come
Oh, I just slid it over and deleted it.
Oh.
I don't know why I did that. It's the quirk of mine, I guess. Well, actually, I see why. I had something on my sheet that I'm copying out of there, but I don't want to, it's not needed for it, so I just kind of skipped past it.
Oh.
Yeah, that's why I did that. Okay, so here it's all equal sign. So K is all equal signs. So I'm just going to go right down the... And here, technically, this is a supply, but once again, don't worry about if that doesn't make sense. I mean, that's... And what we're going to do here, and these are going to be the same. We're going to enter 1 for the supply entering in. So the supply is you, right? You're driving from place to place. So there's 1 of you going in, and then you can't leave yourself at node 2, node 3, node 4, or node 5. You got to just think of yourself in this case. So you're starting at 1, you can't hang out at any of the others, so you have to put a 0, and you have to end up at 6. But here's where there's a little twist on this because of solver, we have to make it work. Instead of being a 1 at -6, it's a -1, and that's just to make solver work. I know but that never changes, so it's just one of those things you just kind of have to accept it. If you want to dig into why that is, I can do that, but we may run out of time. So I'm okay. You don't want me? Okay. And then down here, we're going to do our sum product. So we're going to go total distance equals sum product. And then we're going to just highlight these two like we did before. We're going to multiply our distance by our decision variable. Close parentheses, close. Okay, let's hope I didn't make any mistakes while I was talking, which I tend to do on these. We're going to go to data solver, set the objective cell here. We're going to minimize distance by changing these cells. And what the answer we're going to get in those cells is going to be a 1 or a 0 because of what we did in the supply column. We're forcing a 1 or a 0. Now we shouldn't need to set it. Well, I'll just enter these in and we'll get there and then I'll show you some. Okay, so they're all equal signs. Click OK. Solve. There we go. And mine's wrong.
What's the answer?
It's that F column.
What's the answer 30?
The answer's 32.
And it's minimal, right? We got 30%. Let's go.
And anybody else get 36? Just me?
Yeah, 33.
I'm going to add a constraint and see if it works.
So just add minus 1. Some
Huh. I entered something in wrong. Well, I can go figure it out. You guys seem to have gotten it, so obviously I do that with these where I enter in the wrong.
I feel like I entered in the same thing.
Well, with all the variation and the adding and all of this stuff, sometimes I make little mistakes and you guys do it right. So I'll find mine in a minute. Oh, that's not good for the YouTube thing though, huh? I better fix it while it's still recording. Okay, so you guys go ahead and hop into...
4 is wrong.
Which one?
Number 4, because I have a 1 and a 1 and you have 0 and 0. Like,
And there
no
has to
4,
be a 4
I
right there.
added in.
Yeah. Well, and in my sample one, it's different, and I entered in all the same stuff. So I made an entry error somewhere.
So which one's the number?
Let me give you the sample problem for class is 24, and the homework is 26. So we don't have much time, but you can go ahead and get started in the few minutes we have, or go back and work on the homework for the previous kind. You can do that as well.
So push it from 4.
24, 26, yeah. Huh? Not here. It's 24 and 26, right?
Yes.
And they're both due on Tuesday?
They're both due on Tuesday, yes.
So, are you still doing the reporting?
Yeah, but go ahead and ask what you were gonna ask.
Um,
I'll turn it off eventually.
On 24, there's no arrows going back to places. Should we take that into consideration, or in our own mind come up with?
There's no arrows going, but you don't need arrows going back. That, let me take a look at what you're asking.
Well, like the one we just did, and in.
Oh, it's,
23
yeah, it doesn't matter. Remember, if you have it going, you can have it going back in every possible scenario. It'll just not give it a 1 or a 0.
Oh, I see. Because they're not even arrows; they're just lines.
Yeah, they're just lines.
All right.
So they can go either way. When there's arrows, they're telling you when you can go back and when you can.
Basically over.
That's probably my problem right there.
Alright.
For some reason, I had an extra. I highlighted something I didn't know I highlighted. One thing I will show you guys, just because it came up, one additional kind of constraint you can have if you end up with numbers in this column other than 1 or 0, like 0.5s or something. See this constraint I have right here? I highlighted all these and set it to binary, BIN. That's if you want a 1 or a 0 in those cells, it will do that. In your decision cells, it will do that for you. So when I had 0.5s, I thought, well, I'll try putting them in binary, and it forces a 1 or a 0. So if you, once again, if you ever solve these and end up with a 0.5 or point something, that's what you do.